Okay, we have your problem right here. We've got the performing sequences of transformations to determine congruence. And my iPad is having a little bit of problems, and hopefully this actually renders properly. But this is one of the types of problems that you might get. And of course, if you notice right here, we actually have all the things that you might need to do right up here on top. Okay, so we're going to use those to put in what we need. Now, the first two are very, very straightforward. Rotation and translation are very straightforward. The reflection gets a little bit trickier. Okay, they're actually telling us exactly what to put in, and when we use the tool, so when we go rotation, we use the rotation tool. We notice that our they're actually giving us exactly the same format that they've given us up here. So we can just put that in, the rotation about the point 1, by negative 42 degrees. The rotation about the point 1, by negative 42 degrees. Okay, and as soon as we put that in, we will actually notice that it's rotating it for us. And just to kind of visualize what that is, hopefully this allows me to do so. It doesn't actually allow me to put in that point. You can see where it's rotating around the point 1, and it's about negative 42 degrees. Notice that negative 42 degrees is in a clockwise direction. If it was a positive 42 degrees, it'd be in a counterclockwise direction. Okay, so those are just a couple of things to observe. Okay, so the second thing we're being asked to do is we're being asked to translate by negative 7, 1. And that means we're going to go left 7 places and up 1 place. So the translation, again, it's actually giving us it's giving us the format that the question is actually in. So we don't need to worry so much about that, okay, because it's something we can just copy right down, and it gives us the translation. So just move that image 7 places to the left and 1 place up. The last thing is this reflection over the line y equals 3x plus 1, and that's a bit tricky because when we bring up the reflection tool, the first thing we notice is it's in a different form. It's asking us for 2 points. Okay, so how do we convert y equals 3x plus 1 into point form? And that's really the question that we have here. There's a couple of different types of lines that you might get here. For example, if you got y equals a number, let's say 2, that would indicate that every single point on the line would have the coordinate y equals 2. So that would be pretty straightforward. You could actually just put in 2 for the y spot and choose whatever you want for x. Let's choose 0 and 1 because they're easy to look at. And there's your coordinate points. You could plug them in. If you had x equals, say, negative 3, you could do the same sort of thing, but you've got to remember the x value has got to be negative 3. Okay, but let's just choose what y is because we're not being told what y is. Okay, these two, it would indicate, of course, y. If y is always equal to 2, you'll notice if you draw it out on a graph. I can't actually draw on this graph, but you'll notice if you draw it on a graph that the y value will always be 2, so it's a horizontal line. You'll notice with x equals a number that will be a vertical line. Right? That's interesting. A couple of other things you might notice: if you are given y equals, say, x, or y equals negative x, let's deal with y equals x for starters. Well, of course, no matter what you choose for x, let's just choose 0 and 1 because you can choose a value. No matter what you choose for x and you plug that into this equation, if you plug in 0 instead of x, then y becomes 0. If you plug in 1 for x, then y becomes 1. So that gives you 2 points on the line. And that, of course, is a diagonal line that goes up from left to right. If you have y equals negative x or some form thereof, when you plug in 0 and 1 for x, you'll notice that, well, if you plug in 0 for x, negative 0 is still just 0. But if you plug in 1 for x, then then y is equal to negative 1. So you actually end up with a line that goes downwards from left to right. So those are a couple of common ones that people actually get a bit confused on. But let's look at what we currently have here. We actually have a problem that gives us an equation for y, that we've got to solve for y. But let's do the same thing. Let's just choose our values of x, 0 and 1. We can do that because we know that whatever we plug in for x is going to give us a different value for y. If we plug in 0 for x, then y is equal to 3 times 0 plus 1, so y is equal to 1. If we plug in 1 for x, then y is equal to 3 times 1, that's 3, plus 1, so that's 4. So there's the 2 points that Khan Academy is asking us for when it asks us to reflect over the line y equals 3x plus 1. So let's plug in those 2 points, 0, 1, and 1, 4. We've got 0, 0, 1, and 1, 4. Okay, and as soon as we plug that in, we'll notice that it does that reflection for us. Now, is this transformed figure congruent to the original figure? Yes, it is. It is always going to be congruent so long as you did not do a dilation. If you had to change the size of the image, then it is no longer congruent, but otherwise it is always going to be congruent. Okay. So again, more of these, right? You've got everything given to you here. You've got no lines to convert over, so just plug them right in. You've got a rotation and a translation. You've got a rotation followed by a translation. Okay, so the rotation is about the points 1, 1 by 121 degrees. So all we got to do is plug in what we're given by 121 degrees. All right, that's of course a counterclockwise rotation of 121 degrees. See, it's already rotated, and a translation by 8, negative 3. So we just plug in our translation by 8, which is 8 to the right, and negative 3 is of course 3 down. And that's it for these questions. And these 2 questions are common questions that you might get in. Of course, if you forget to check the box, it's not going to mark it wrong for you. It tells you there are still more parts of this question to answer. So you can see no dilation to do here. So it must be congruent to the original figure, and you can check answer, and then it is going to mark it correct for you. And you'll notice right there that it did mark it correct. Okay, so if you forget to check that box, no worries on that. So all of these problems in this particular problem set are all very similar in this particular, just like this. It's when you get to the next problem set, and I'm more than happy to make another video for that problem set to show you how to do this when you don't have the information given to you. You have to actually choose things for yourself to go in there. So if you need that, just let me know, and I'll send one to you.